Riley, yes. Giselle, Landon, no. Daniel, yes. Parker, no. Ethan, Jalen, yes. Morgan, no. Paula, yes. Wendy, yes. Elsa, Katie. And I have Alicio, yes. Kevin, Jesus, Linda, Anderson. All right, ladies and gentlemen. So you need to go back into the lab. And in the lab, ladies and gentlemen, on this side back there are all of your samples, dried and waiting for you. So they're on this side of the middle distribution table. You need to make at least 3 observations of your dry PBI2. That is what is left in the container today. Then you need to find its mass with the filter paper. So find the mass of the container just as it sits right now with all the filter papers in it. That mass goes here. You then take this mass here minus these 2. Now, if you have multiple filter papers in here, you have to subtract them all. So we have the mass of the dry PBI, the beaker, and all your filter papers. Subtract the filter papers and the beakers from that, and you will be left with the mass of dry PBI. Okay? That is what you need to get, and you need to make your 3 observations. When you are done with that, the paper goes into the garbage can, and the beaker goes back by the 2 funnels, the 2 white funnels that are sitting there. Go to your seats. Make sure you take and type in your numbers into either group 1 or group 2 here for your volume. And then I will collect all of them from you so that we can then get a class average for you guys. We cannot give you the all class average until tomorrow, even though one will fill in. Well, it won't fill in on yours. You'll have to fill it in. So this is what we need to get going as a group. You have got 10 minutes, ladies and gentlemen. Get your mask, get your observations, and get that cleaned up. Let's go, let's go, let's go. What do you mean? As long as they're good observations, yes. Both clerical and odorless, things like that, absolutely fine. Yep, no problem. The filter papers get thrown away and you put your beaker right over here.
Can we touch it?
You can touch it if you want, but wash your hands afterwards because it is a lead substance.
It's like powder. It has a powder texture. I got 2.59. I have a
I need you to calculate that final mass as soon as you can.
Minus 0.918. We're gonna need some.
The papers go in the garbage and then you have your beer.
You don't measure the beaker. I was better than 11. Are you sure you measure the beaker too? Mass of
No, I want your beaker if you're done. You're done? That away.
And how much did it save this? I actually don't want to try this.
You can't throw that stuff down the drain. That was the reason I asked you to bring it back here when you were done. Now run lots of water down that sink. Well, it helps a little bit, but what doesn't help is the not listening part. Because that lead that you're putting into the water system of Green Bay.
So, all I done is cheap. Look at what? Oh, yeah.
No, not really. Plenty of water down that sink. Yes. Well, if you want just the mass of that yellow stuff, what do you have to get rid of? The mass of what? A little bit to above. The mass of the filter paper is on one line, the mass of the beaker is on the other. If you take that bottom number and subtract the two boxes above it, you should get just the mass of the yellow precipitate. That can't be 77.096. It can't be. This is 82 and that's 78. If I just subtract that, that's good.
So what?
minus
Just
this,
take mine.
minus
You
this.
put it. You put
minus
something in there. I put her.
all.
Okay, it's your very last one. Be ready. You're 4 by 9? Oh. Wait, there's no 4 less. So it's 4 by 8 is all the same day? Yeah. I would not be excited for you either. Are they separated at least? Oh, it's separated? Okay. And I think.
Okay. So you're going to tell me your masses, each group, of the precipitate that you got. So our 5 milliliter group. And if there's one of you or two of you, well, just let me know. Okay, Ethan, go ahead. 0.607. You all need to copy this into yours as well. That's 0.607 grams. Was there a second group that did 5 milliliters? Okay, 10 milliliters. 1.374. Was there a second group that did that? Okay. 15 milliliter. Was there a second group? 20 milliliter. 405. Was there a second group? 25 milliliter. What? This is the mass of precipitate. Should be the bottom number from your table. 25. Someone did 25. Who did it, please? 25. Then tell me what your mass is. Of dry PB, right? Yes. I think I did it wrong. What is your number? 71.9. Okay, now subtract your beaker and both filter papers from the mass you got today, or one filter paper. Yes. I got 2.402. 2.402. We'll come back to you in a second, Denia. 30. Was there a second 30 group? What do you got, Denia?
It's 2.349.
349?
Yeah.
Good. Okay. Do not copy the all-class average into your data table. That is just your numbers. Do not copy the all-class average. That I have to give you tomorrow. So everything in these three, you copy into your data table. That is the Google Sheet that came with the lab. Okay. Anyone need more time with the table? All right. So here's what I want you to do. Highlight the entire table, ladies and gentlemen. Even that all-class average that doesn't have numbers in it. Control C on your keyboard. Open up your lab report, the limiting reactant lab document. Where it says class data table, get your cursor so that it is right underneath where it says import from Google Sheet file. and then hit Control V. Yes, you want it linked to the spreadsheet, so paste it linked. It will put your table in there. The reason you want to paste it linked is because tomorrow I will give you the all class average, and you will not have to re-put this into your lab. Tomorrow, when you go into your data table and you update this last column, it will give us a button on here that says update. You will hit that and it will just put in the last of the numbers for you. You will not need to redo it. Okay? So this table, just like this, should be in here. Any questions? Okay. Next, in the Google Sheet, there is a tab that says graph. I believe it says lab graph on yours, correct? Please look and please tell me. Okay, graph, thank you. So it should look like this. There are 2 lines on there right now. The blue line, ladies and gentlemen, is the predicted masses that we should have gotten. This line here is the masses that you got. The third line is not on there yet because the all-class average is not on there. Actually, it is in this lab. It just happens that the all-class average and your class average are laying right on top of one another. Okay? They're literally the exact same numbers. So this line is representing both the class average and the all-class average. Tomorrow, when you update the all-class average and those numbers change, then you will see the 2 lines appear because they will not be laying one on top of the other. Now, you need to change 3 things, ladies and gentlemen. And I'm going to show you how to do that right now. Go up to Edit Chart. Click on it. Edit Chart. Go to Customize. So of the Setup and the Customize option, hit Customize. And now, ladies and gentlemen, go down to Chart and Axis Titles and click on it. Now, this drop-down menu will let you change the title here. It will also let you change the horizontal axis title and the vertical axis title. You need to change these to what variable they are showing you. Now, you need a variable and you need a unit. If you look at the numbers 5, 10, 15, 20, 25, and 30, you should be able to figure out from your data table what these numbers represent. So what did we measure 5, 10, 15, 20, 25, and 30? Not asking you to tell me, I'm asking you to figure it out. So you need to change this by clicking on the horizontal axis label and going in the text title box and changing it to read what you want it to read. Then I expect you to do the same for the y-axis. Again, our numbers are 0, 1, 2, and 3. You should know what they mean. If not, look up here, and this might help you figure out what those numbers are. And then you need to give it a title. Now, the title for chemistry labs is the x-axis variable versus the y-axis variable. That should be your title, this versus this. You've got 5 minutes to get that done, ladies and gentlemen. If you need to work with your lab partner, go ahead and work with your lab partner. This is your graph, ladies and gentlemen. If you want to change fonts or play around with font sizes or things like that, I'm absolutely fine. Yes. Either one is absolutely fine. Okay? Either one is fine. Please make sure that after you put your label on, you put a unit. What do these numbers mean? You've told me what they've measured. Now tell me what they mean. What is this 25, 20, 15, 5, 10? What is that measuring? What is that of? Alicia, did you have a question? Okay. Yes, sir. Your graph is what? Okay, go to the lab page. Get rid of the G. Get rid of the G. Now go back to your graph. Go back to the your graph. So now go into the lab, click on that, and hit that update arrow.
Oh, I can try to start.
So you were missing a point because it can't graph letters. So I appreciate you putting the unit in there. But if any of your numbers in your data table have units by them, it will not graph them. All right, anybody need more time with their titles? Okay, some of you may have already done this, but I'm going to show you now how to put this into your lab document. Do not hit copy chart. For some reason, if you copy this chart in, and Alicia will attest to that, because you remember how you had that real thin looking graph just a second ago, and then it changed? I do not like the way Google brings in a graph into a document. It does not make a very clear object. I'm going to show you how to do it so that you get a nice, clear, easy to read graph. Go into your document. Go down under where it says graph, 3 points. Again, get your cursor right underneath where it says import from Google Sheet file. Are you ready? Anyone need more time? Here we go. Insert. Chart from sheets. Insert chart from sheets. Now, in this corner right up here should be the last Google Sheet you were working on. Click on it. And then hit insert. Now, I know you're looking at a picture of the table, but it's going to ask you which chart you want to do now. You should only have one chart there. This should have the labels changed and things. Click on that one chart and hit import. And it will bring it into your lab for you in a nice, crisp, clean image. Are you good, or do you want me to go through that again? Now, again, this is not your final graph. We will need to update this tomorrow, okay? And we will do that after I give you the last of the numbers. But you will not have to re-put them into your document. You will simply need to go to your document and hit the update button, and I will show you how to do that tomorrow. All right. Let's go to number 4, percent yield. Okay? Now, you have to do this calculation. So you are going to click on this formula and get your cursor up where it says experimental value. And for the experimental value, ladies and gentlemen, you are going to type in the mass that you just gave me to put into the data table. That is your experimental value. That is what you got from doing the experiment. So type in that number of grams, whatever it was. Then highlight accepted value. For the accepted value, ladies and gentlemen, you are going to use one of these numbers in blue. This is what you should have gotten. Now, again, it depends on what volume you had as to which one of these you are going to use. But if you were the 5 milliliter, you're going to use 0.58. The 10, you're going to use 1.15. 1.73 grams for the 15. 2.31 for the 20, the 25, and the 30. So now, ladies and gentlemen, you put that number into the bottom. You divide the 2, you take it times 100, and you get an answer. And your answer should be in percent. When you get your answer here, bring it down here. Okay? Bring it down here to whichever one you did. Yes. A lot of you probably did because you got more than you were supposed to. What? Go to 2 places beyond the decimal. Or actually, I'm sorry. Go to 1 place beyond the decimal. 100 point whatever, 99 point whatever. 1 place beyond the decimal for this. So yes, anyone whose number here is higher than here, you are going to have over 100%. Anyone whose number here is lower than this number here, you are going to have less than 100%. Okay? Now, in theory, you shouldn't have gotten more than 100%. But in practice, you probably did because you didn't get all of the ions out of solution. That is how you end up with over 100%. If you didn't get all of the ions rinsed out of your solution. Now, if you're a little less, maybe some leaked through the filter paper, maybe some ended up, splashing out or something like that. There are explanations for either one. Questions? Now, you have a choice, ladies and gentlemen. The group for 10 and the group for 25. You will have a different number than the other group who did that same amount. Okay? When I give you time to work, you have 2 choices. You can do the calculation for class average for every group you did not do. So whichever ones you didn't do, you could do the calculation and figure out the percent error to fill in this part down below here, or you can get together, you can talk to other people and you can get their percent error from them. It's up to you. You either have to do the calculation or you have to talk to people. I know 2 terrible choices, but you got to do one or the other. Now, hang on because I'm not giving you time to work yet. Okay? Let's go to the questions. Okay? What was the purpose of filtering the solution and rinsing the precipitate? I think we have more than covered that. There was a reason we kept adding water to it. We just talked about it a second ago. Now, what did the filter paper do? What did it catch? What didn't it catch? What did rinsing do? What was it trying to get rid of? You should answer that. Number 2, in which trial were there 2 limiting reactants? You know that because we've already filled in the table below for number 3. So you tell me what volumes was the one where there were 2 limiting reactants, and you could base it off of the volume of sodium iodide because the volume of lead nitrate was the same in every one. You need to tell me which one had 2 limiting reactants. And then finally, ladies and gentlemen, this is the toughest question here. I'll give it to you, and then I will give you time to work. Compare the number of moles of reactants and products that you calculated in calculations 1 or 2 of this trial to the ratio in the balanced equation. What conclusion can you draw? Okay, so let's talk about this real quick. Okay, first of all, there were 2 ratios in this lab. Ratio 1. That was 1 ratio. This was the second ratio. That was the second ratio that you used. That's the ratios that they're talking about in this problem. Okay? If I were you, I would go back to this data table. Okay? And what it's asking you to do is compare the moles of product to these moles here. Now, look at your moles of product here. In the last 3, what do you notice about your moles of product? They are the same. They are not changing. Okay? So, look at your reactants here. What do you notice about these moles and what do you notice about these moles? These are doing what? Increasing every time. Can these numbers be responsible for this staying the same? That's what you have to ask yourself. Can these numbers going up be responsible for these numbers staying the same? Can these numbers staying the same be responsible for these numbers staying the same? And then the opposite here. What are these 3 numbers doing? They're increasing. Here, our numbers are staying the same. Can numbers that stay the same be responsible for these numbers? I don't know. You're going to have to tell me. But here's the other thing. Okay, I at least understand this. These are the same, right? What do you notice about these? They are not the same. What does that have to do with those ratios? What does that have to do with those ratios? Okay? Now, ladies and gentlemen, I'm done. You need to finish the questions. You need to get the percent yields from other groups, or you can do it on your own. And you need to answer these 3 questions. Because tomorrow when you come in, I will give you the numbers you need to update your all-class average, to update your graph, and you will then turn this in during class tomorrow. Because everything should be done. Katie.
Some people have an AP test. Can you influence the numbers?
Yes, I will find a way to do that. Okay, I will find a way to do that. I will send you the numbers in an email if you're not here tomorrow, so that you can put them into that. That would be fine. And then get it turned in as soon as by the end of the day for those of you who aren't in class tomorrow. But if you're in class, you should be able to get it done and turned in. Okay? If you finish this, you've got problems to work on, practice for your test in 48 hours, ladies and gentlemen. Go to work. Go to work, go to work, go to work. If you have questions, call me over, but you should have everything you need. Go to work.
May you please search?
Go ahead.
What? Oh, 107. 25.
100. Oh,
Yeah.
about that.
What is it?
Yeah. 147.
Oh, so for 25, you have 101.7.
What was the
5%?
5 milliliters?
5 million was 104.7.
And then this time,
119. Yeah, 119.5.
and then it was 20.
104.1. Is